Hello guys and welcome back. So today we are going to discuss about semantic model in Microsoft Power BI. So to start with, I have taken one Excel file. So let's suppose whenever we work on any of the data requirement, we used to know that how the business or the business function works for that particular organization. So suppose there is some any retail industry who is selling his products. So the data or the raw data will look something similar to this one. So here you can see in this Excel, I have taken it for an example. We have an order ID, then we have the priority of the order, the discount on the order, the unit price, the shipping cost, customer ID, customer name, shipment mode, customer segment, and product details, and a product name you can see, and then the country, region, state of province, city, and then we have other information like when the order was placed, when the shipment was done, uh, how much is the profit for that order, quantity ordered new, and then the sales information like what is the total sales value in that. So as you can see that everything is included into a single file. Now, whichever software or application we work with, in for the analytical purpose, we need to break down this raw data into a star schema or extended star schema, which is also known as Snowflake schema. So in this session, we will learn like what star schema is. So as you can see, if we take an example of a customer ID is the unique ID of a customer, and the respective details like customer name and customer segment, all will be related to that particular customer ID. Similarly, a product ID is a unique ID for a product. So for for example, for one product ID, there can't be two product categories or two product subcategories or any other product related information. That means for each particular product ID, these information will remain constant. In that case, what we do is basically we create a dimension table, which is also known as a master data table in generic terms. So how we will do that and how we will derive. So we will um, work on this Excel and see that how that works and how it is helpful for the analysis purpose, because query in terms of query performance or in terms of designing, it will help. So to simplify the data as well. So to start with, what we will do, we will copy all the columns here. So this is how the database tables are being designed, whether it's a SQL, whether it is SAP HANA or any other relational database system. So we will paste it over here, and you can see these are the columns that are present in our data set. Now we will have product related information in separate table. So let's suppose this is one table, which is product dimension table. So this is product dimension table, for example. Let me minimize a bit. Okay. So this is one table. And what we will do is we will create it like this and we will do some color coding. Let's suppose, yeah. And then we can also create a country table or a location table. So we can name as per our needs. So let's suppose we create a location location dimension. And what will be the unique key for location dimension? It will be the postal code. So we will take postal code, city, state of province, all these. Okay. So what we will do is we will put it over here. So this is the key. Sorry. So this is the primary key. This is the primary key for this table. Um, okay. Yeah. So this is another table that we have created. So these are two-dimension tables, and for this is the primary key. Okay. Now, we'll see a customer related information. So we also have a customer ID. So let's suppose we have another table, customer ID, customer name, customer segment. Anything else? Yeah, I think this is it for the customer table, but in many of the cases, we will also have more information related to customer, like the address of the customer, the contact details of the customer. But because this is a sample data set, we have only limited information. But in real time or a real business case, you will have a lot more number of information, and then you need to design. So this is how the star schema works. So this is the primary key for the customer dimension table. So to before starting with the Power BI semantic modeling, I think this is really important to understand how the star schema works. Now we have the main table, which is the order table, and this is our fact table. So wherever we have the transactional related information is known as a fact table. Okay. So as you know that now we have a primary key called postal code over here. So we will keep the postal code and we'll remove all these from the fact table. This is how we will design. So we will remove city, state, region, and country. Gone. Okay. And then product base margin. Okay, so for product table, we have product ID as the primary key. So we will keep the primary key in the table and we'll remove the remaining information about the product. Okay. And for the customer ID, we have the customer ID. We'll keep customer ID. We will remove customer name and customer segment. Yeah. So you can see how we have reduced the size of the main table, which is the transaction data. Now we have order ID, order priority, discount. So these are the information which can be anything whenever a transaction happens. So for a particular order, the order priority can be selected, the discount can be given on a particular order, a unit price will be based on the product. So this can also be linked to the product in some cases, like what is the unit price for that product. But let's keep it separate for now. Okay, so in layman terms, how we can design a star schema is we will keep everything which is relevant to a particular business transaction as a fact table, and anything which is constant or which is kind of a property of a dimension. For example, customer ID. So customer ID is a property of customer. So customer ID is unique, and then we will have customer name, customer segment, customer address, customer contact details, and so on. Similarly, for the location dimension, where the transaction has happened or the sales has been happened, so we will keep the location dimension as postal code is the main, and from postal code these can be easily derived. Similarly for the product. Okay, now we have seen there is an order date and shipment date as well. Now this the granularity of this order date and shipment date is DDMMYY. Now in when we do analysis, we many of the times we need like monthly analysis, like how much our sales is working throughout the year, like starting from January to December, or first quarter, or quarterly analysis, or yearly analysis to see the trend. So for that purpose, we may need to create another date dimension table. So this will be date dimension table. So this will contain a date, which is basically DDMMYY, and this will be the primary key of this table. And then it will contain month. Maybe one will be month number, like 1, 2, 3, 4 till 12. So we can name it a month number for the sake of understanding. Then we will have month name. Then we'll have week number. I'll have, sorry, week name. Then we can have year. Yeah, yeah. We can also have day number, which will be from 1 to 31 based on which month it is. And we can also have day name. Okay. So this is another table which we can create directly in Power BI using several options, which we will see later. Okay. Tutorial. Yeah. Okay. So this is how we have 4-dimension tables and one fact table. So this is order fact. So this is order fact table. Okay. Okay. So now it is pretty much clear. So how we can design. So now our fact table, which is the transaction, has only these values. And what else we can identify is maybe we can color code with some orange color or something, product ID, postal code, and customer ID. These are the foreign keys. So we can write foreign key. Again, this is also foreign key. This is also foreign key. And this is the primary key of the fact table. So order ID is the primary key of the fact table, and these are the foreign keys. Foreign keys are used to relate the fact table with the dimension table. So as we can see now, this customer ID and can be related to the dimension tables. So customer ID to the customer ID. So there will be linking. We can use this one. Yeah. So customer ID to customer ID like this. This is one. Yeah. Yeah. Let me do it in another way. Yeah. So let's suppose this is one, and then for product ID, sorry, for postal code, this will go to the postal code. Like this. It's a bit weird in Excel, but yeah. So this goes to the postal code, and the third one, which is product ID, will go to the product ID. So this is how we will join the tables, and then we have the order date and shipment date. So any date can be joined to the date dimension so that we can do the analysis on different granularity. So we will also have the joins from here. Maybe better to use this one. Let's see. Yeah. So this is one. And we can create another date table for the shipment as well. So maybe we will see it later, like because we have different dates, we can't map it to the same dimension table. So we can create date dimension 1 and date dimension 2. And we'll see in later how we will do it in Power BI. Basically here, and we can put over here, then move this to here. Yeah, and slightly easier. So for these as well, let me change the shape so that it will be clear. So product ID goes to product ID. It's a bit weird. Okay, let's continue with this one. It's still easy to understand. So this is how we can design a star schema. You can see that we started with the order table with all the fields available for the transaction related information. Then we created a new sheet. We copied all the information which is available. And then we try to find out which are related to a master data or kind of a dimension, which doesn't change it. So if you look at what is one thing common in dimension table is it doesn't changes more frequently. However, the fact table is a kind of a transaction which happens every now and then. So you can see the location. If there is a postal code, then the country, region, state, and province and city, everything will remain the same unless there is a change in name of any city or something in future. But that is very rare case. Otherwise, it remains constant. Similarly, for a customer ID, the customer name and the customer segment or the location, everything remains the same. So in case the customer changes his office location or the customer changes his company name, then these will be updated, but that is also not very frequent. That is very rare cases. Similar is the case with product ID. Similar is the case with date will always remain as is. So as you can see, dimension tables are pretty much constant tables. However, fact table is a kind of a transaction which happens every now and then. Okay, so this is how uh, we created a star schema. Now, what is the advantage we got by creating a star schema? So I will just demonstrate the advantage. Now, if we will run a query, so this is a small data set. As you can see, the number of records is only around 20K. Okay. But in real business scenarios, it might be in millions if we include everything in the table. So it will be in millions. So when we will run a query to read such kind of a table, it will be very slow because it will be the execution will need to scan all the data, which will be a very huge count of the data, and also because there are more number of rows because the table size is huge, it will take a lot of time to read the data. So the performance wise, it is it is very slow. Second thing is it will take more memory because, for example, here you can see this one. The customer ID is the same, so the customer name and customer segment will also remain the same. But because we have included everything in the same table, we are storing these multiple times. Okay. So if we count the cells, let's count the cell before changing it. So if we count the cell, I'm not sure if this is showing the count of the cell, but it is around 48,000. Okay. Yeah, this is the count of the cell. So because it is 2000 records and then into the number of columns. So it is around 50K records or 50K cells it is taking to store the data. For a smaller set of data, you can see it is taking 50K. Now what we will do, we will copy this sheet. So let's copy and move to the end. Okay. Sorry, I didn't copy it. Okay, let's create a copy and move to the end. Okay, this is order two. Now we will change this. We will not change this one. We know that it is around 50K records. Now we will change as per our needs. So first thing what we'll do, we will create a customer table. So this is a customer ID, customer name, and customer segment. We will cut from here. Sorry. So what we can do, let's cut here and paste this so that we can cut these columns, create another one, and this one we will name as customer dimension. Okay. So this is our one table and this is our header. Now what we can do, we can select all, go to the data and remove duplicates and remove it. So you can see 761 duplicate values deleted. Now we can remove this. This table is not required. Delete. Now we have a product information. So till here. Sorry, I did one mistake. My bad. We will need the customer dimension, the customer ID. Yeah. So start here and instead of cutting, we will copy it and paste it over here. Go to the data, remove duplicates and remove. Okay, so this is our customer dimension table. You can highlight the header. Now we will go and we can delete these two. This is not needed in this table. Now similarly for the product, we will copy till product base margin. We'll copy this. We will go to new sheet and then we will remove duplicates. So there is no duplicate found. That's okay. So this is product dimension. And then so basically, because this is a sample file, that is why there are not many duplicates. But in a real business scenario, there will be so many duplicates if we remove these kind of master data. Okay, so deleted it. Yeah, for the country, there will be many duplicates, I can assume. So let's copy this and create a country dimension table, paste it, and here you can remove the duplicates. And you can see almost half the duplicates has been removed. So this is location dimension table. And now we can delete all except postal code. So product ID has been removed. Order date, shipment date is okay. Okay. So our table is ready. Now, if we will count it, it is only 27,000. So you can see it is almost reduced by 50%, but only 50% because we have a smaller set of records. But in real term scenario, we will have more information about the customer, more information about the product, more information about the location and so on. So then it will be once you develop a star schema, this will reduce the large number of count. So this is order fact table. Okay. So this is how it is designed. Now what will happen if any new transaction comes in, for example, in future? So this is how you have developed your database. Now, if any new transaction comes with a order ID 90,000, let's suppose this is high, and let's suppose everything is the same. Okay. And product ID can be duplicate, not an issue. So let's suppose this is a product ID. The same product, the same customer has purchased again. Maybe we can update the date. So what will happen? It will not require those additional fields which we have removed from this. So by using the product ID only, it can fetch those information in the runtime when we will develop the schema or the semantic model in Power BI. Okay, so this is pretty much clear to everyone. If not, maybe you can put your questions in the comment section and I will try to help you out. So this is how we can design a database model or a semantic model. So this was one of the use case, and here we have designed a star schema. There is another concept called extended star schema or Snowflake schema. Now, what is Snowflake schema? It is basically if you have two different tables for your fact table, but one of that table is not directly related to your fact table. For example, product category is one table. Okay. So example I can give, and product subcategory information is in separate table. Okay. So product subcategory is a separate table and subcategory related information are over here. Let's suppose info 1, info 2, kind of. So everything related to the subcategory, those information are in this table. Okay. So then, so this is product subcategory dimension table. So now what will happen? This is the primary key of this table, and it has also similar kind of informations, but our fact table doesn't has product subcategory. Okay, it only have a product ID. So that means this fact table can't directly link to the product subdimension table, subcategory dimension table. So in that case, what will happen? This product ID as a foreign key is linked to this product dimension table, and this as a foreign key of this dimension table is, sorry, not this one. This as a foreign key of this dimension table is linked to the subcategory dimension table. Yeah. So this is called extended star schema. What does it mean is basically our fact table is not directly linked to one of the dimension table, but our fact table is linked to one dimension table, and that dimension table is again linked to another dimension table, which is we can say as extended schema or a snowflake schema. So this is how it works. So this can also be achieved in Power BI, but there are some pros and cons which we will learn later. So for this session, I just wanted to include this thing because before proceeding into modeling the data in Power BI, we need to understand the basics behind it. So this is how you can analyze your data in an Excel, and then you can design your database model. So these table that we have designed, it can be achieved from anything. So what will be the examples? What will be the examples? So basically there will be possibility that all these tables. So this is one table, this is another table, this is another table, this is another table, this is another table, and this is another table, and maybe this is another table. So there can be any possibilities. So let's suppose use case 1. So in use case 1, all these tables are created in SQL Server, for example. So all these tables are in SQL Server. Okay. So we have all these tables in SQL Server and everything is maintained. So whatever business application is built on top of it is writing the data in SQL Server. And then we can connect to Power BI. Okay. And we can create similar models in Power BI, and then we can do the semantics. This is one way. Okay. So what here we can do is basically like this. Okay. So it should be one way. Yeah. So we can connect to the SQL server and we can fetch all the data, all the tables from SQL server to Power BI. And then in the Power BI, we can join the models based on the requirement. This is one case. So this is connection SQL server to Power BI. SQL server to Power BI connection it is. And then what we will do? Create semantic models in Power BI. So we will use join condition. So we will take it as our fact table and then we will join just following this same functionality. This is one option. So this is option one. Option one of use case one. Second option would be option two would be you can create a view in the SQL by doing the join. Okay. So you have all the tables available in the SQL server. Now, what you can do, create SQL view using table view. So you can join all these tables in the SQL query itself, and then you can fetch that query to Power BI. So this will be a straightforward one for the Power BI. So Power BI do not need to do much, and then it will have the semantic model. Now, how we will decide whether we go with option one and option two is basically we go with option two in case because we can also do some modification or changes. So if we will maintain these models, master data tables as well, there is an option to manually patch the data itself. Otherwise, we need to patch the data in the backend. That is one case. Another case is it depends like how it is going to impact your backend system. So one way is like if it is too heavy for the SQL query to run, it's a huge amount of data, and doing n number of complex joins is impacting your SQL server. Then what you can do, you can just replicate the data in Power BI and then do the stuff. So it is case by case how you can design it. Another case would be so SQL server. So SQL server is providing you, or maybe we will not name it as an SQL server. For example, source one. Source one. So this is one application which the organization is using, and so each data is coming from different sources. For example, so this is from source one, which contains the location information. Order information is in source three. Customer information, let's suppose, is also in source one, source two. So in these cases, this option two is really useful because you don't have everything available in one source but it is uh, distributed in multiple sources based on the software you are using. So in that case, you can fetch the data in Power BI and then do the semantic modeling in the Power BI. Then you have source 3 and all these information. So let's suppose date dimension you can create in Power BI itself. So this is within Power BI, you can create date dimension. So there is no problem. You do not need to always fetch the date dimension. You can create in Power BI itself. And let's suppose this is also source 3. Yeah. So this is how you can connect to different sources and then replicate the data to Power BI and then do the semantic modeling based on the drawing. So this is it for this session. Maybe we will do the demo in the next session where we will use the same data set. So what I will do, I will create, um, I will upload few of the tables in the SQL server and we'll keep some of them as an Excel sheet so that we can leverage different sources. So we will uh, upload one data from SQL, one data from Excel, and we'll create time dimension directly in Power BI so that it will have almost three kind of tables, one from connected to SQL, one from Excel, and the third one directly in the Power BI using Dex query or M query, which is also known as Power Query. So thank you everyone. So this is what I want to conclude in this session. So in the next session, we will do the demo where we will see how we can achieve all this in Power BI. Okay, thank you everyone. If you like content, please do subscribe and like the video. You can also provide your feedback if you think that any improvement or any clarity is needed. So then I will work on that and we'll try to work together on those things. Yeah, so stay connected. Thank you so much.